Hey guys, Mr. Sarley here. The secret word is remember me because I want to go over some of the midterm questions. So I felt like starting this week's homework. Here's a type of problem that we did just a little bit at the end of this last unit. It says a recipe calls for 1/5 cup of water for every 1/4 cup of milk. How many cups of water are needed per cup of milk? The only thing that makes these questions a little tricky is it's a little difficult to see what it's asking us to find. But if we look at this last sentence, how many cups of water are needed per cup of milk? That last phrase, per cup of milk, is helping me know that we're looking for 1 cup of milk. And then all we need to find out is how many cups of water are going to be the same as that. So a couple of ways to do this. If I'm trying to get from 1/4 to 1 whole, I know that 1 whole is the same as 4/4. So really all I need to do is take 1/4 and multiply it by 4 to get 4/4. And when I do the same thing on the top, I get 1/5 of water times 4 would become 4/5 of water. So how many cups of water are needed per cup of milk? The answer is 4/5 cups of water. So this is basically a scale up by multiplying strategy. You could have also scaled up by adding. Every time the cups of water goes up by 1/5, the cups of milk are going to go up by 1/4. And if we scale up to 4/4 or whole of milk, we end up with the same answer, 4/5 cup of water. Alright, hopefully you're realizing that you could ask for 1 cup of one of the things, like water, or 1 cup of the milk. So it's almost like this problem has 2 unit rates, and you just have to read carefully to see what it's asking. So number 2 says, solve the same problem as above, but now find how many cups of milk are needed per cup of water. So this time, we're trying to go up to 1 cup of water. And if I look up here, if I'm trying to get from 1/5 to 1 whole, I know that 5/5 make a whole. So I'm just going to multiply my 1/5 times 5. And then to get an equivalent ratio, I'm going to multiply 1/4 by 5. And that should give me an answer of 5/4, which is the same as 1 whole with 1/4 left over. And that is cups of milk. Okay, so the last question on Thursday's midterm involved taking, I think it was 7/8 and writing it in decimal form. And about 70% of the grade got it right, which means 30%, or like 3 out of every 10 of you, didn't really know how to do that. So I'm going to show how to do it for number 1, and then number 2, it's going to be weird because it's going to be repeating. So let's say you have a fraction like 3/8, and you want to write it as a decimal. It helps to know that fractions are basically division problems in disguise. Like 3/8 is equivalent to 3 divided by 8. And once we know that we can use long division to find the decimal form of 3/8. So I'm going to start with 3, and then we're dividing it into 8. So the 8 would go outside because that's what we're dividing by. And obviously 8 doesn't go into 3, so to start off right here, we're going to need to add a decimal point and a 0 in the tens place. I'm going to bring up the decimal point, and you can even put a 0 in front here. And now I know that 8 goes into 30 3 times, and then 8 times 3 is 24, which gives me a remainder of 6. So I see that this is going to go on. So I'm going to go ahead and add a 0 to the hundredths place and bring that down. Next, I know that 8 times 7 would be 56. And if I were to subtract that, I'd have a remainder of 4. So I can't really tell what it's doing yet, if it's going to go on forever or not, so I'm going to keep going. But right here, I notice something, because 8 times 5 is exactly 40. So I know that this decimal is going to end, and I have my answer. 3/8 is equivalent to 375 thousandths. And written like this, this is basically what we just figured out, is that there's a way to get from 3/8 to 375 thousandths. Alright, so the same for number 2, write 2/9 in decimal form. So 2/9 is equivalent to 2 divided by 9, and we can use long division to figure out what the decimal form is going to look like. So we put the 2 on the inside, divided by 9, and already we're going to have to add a 0 to the tens place so that the 9 can go into the number. So starting off like this, 9 goes into 20 twice. 9 times 2 is 18. Alright, so I have a 2, and if I add a 0 to the hundredths place and bring it down, I see that I have the exact same thing happening. 9 goes into 20 is what we started with. Now we have 9 going into 20 again, which I know is 2. And 9 times 2 is 18. Subtract it. Okay, so it looks like what's going to happen here, and this is just going to keep happening over and over again. So instead of continuing until you die, I would say a better idea would be to write it like this, 0.2, with this little bar over the 2. And that's actually a mathematical bar. I don't even know what they call it, but it basically means that that 2 goes on through infinity, just goes on forever. And that's how you would write the decimal form of 2/9. Alright, so on to the back. On the midterm, there were a lot of mistakes on this problem as well as this problem, which I was a little surprised with. But now that I know that, I can definitely spend some time on it so you're comfortable with it. So this problem said the cost of oranges in a grocery store is directly proportional to the number of oranges purchased. Jerry paid $2.52 for 6 oranges. And then they tell us a couple more things. They say P represents the cost. So I'm just going to record that somewhere. P is the cost in dollars. And then N represents the number of oranges. So N equals the number of oranges. Which equation best represents this relationship? Alright, so I know to write an equation, like a proportional equation, I need to know the constant of proportionality or the unit rate, meaning I need to know how much one orange costs. Already, that tells me that this one is wrong because it's taking the price of 6 oranges and multiplying it by the number of oranges. I know that C is wrong because that's taking 6, which isn't the cost of 1 orange, and multiplying it by the number of oranges. In fact, I could even reason that D is wrong because I know that $15 is not the price of 1 orange, so it wouldn't make sense to multiply that by the number of oranges. So I'm pretty sure, using process of elimination, just getting rid of the answers that don't make sense, that the answer has to be A. But you can also use long division to find the unit rate. So it's $2.52 for 6 oranges. So let's divide and figure out how much 1 orange costs. So we can't go into the 2, but 6 goes into 25 4 times, because 6 times 4 is 24. I bring down the 2 in the hundredths place, and then 6 goes into 12 exactly twice, which means we're not going to have any remainder. So this is the price of any 1 orange. So basically, if I take 42 cents and I multiply it by the number of oranges, which here they say to use N, it's going to equal the cost or the price, which is P. And so that's A, it's just a little bit turned around. They just wrote the P first, and then the cost of one orange with an N next to it, which means to multiply. So that would be the correct equation for that state test question. And then if you look at this one, again, about 40% of the grade got this one wrong. And I think I know which one confused people. So for this one, it says bananas cost 45 cents per pound. Write an equation to find C, the total cost, of P pounds of banana. You know what they probably did, these evil state test people? They probably, instead of having P represent the price, they had P represent the pounds. So you may have looked at this one and said, oh, 0.45 times C equals P, which must mean price, so that must work. But that's wrong, because P is the number of pounds. C is the cost. So I know that I need to take the unit rate, the cost per pound. I'm going to need to multiply it by the number of pounds, and it's going to equal C, which is equivalent to this one. They just put the C first. So I imagine C confused a couple of people. I had one student ask me, isn't B and A identical to each other? Because they thought that if you have a number next to the letter, it means to add, maybe. But adding isn't the same as multiplication, and that actually means we're multiplying, so it's not the same as B. And D is just kind of crazy. All right, on to what was the hardest question on the exam for a lot of people. I think only 40% of the grade got it right, which means 60% got it wrong. This is basically 3 integer problems disguised as one long expression. And in a problem like this, all we have are 2 operations. We have subtraction and addition. And if we're following the order of operations, or PEMDAS, addition and subtraction are the same step, and you just do it from left to right. So basically, to solve this, first, you would need to figure out what that equals. Then whatever that answer is, you would have to add 0.4, and then whatever that answer is, you'd have to add negative 3/4. So I'm going to go through this one in detail so that if you didn't know how to do it, or you really want to check your answers, you can get it. Alright, so to get this problem right, you have to be really good with fractions and decimals. Otherwise, you can't even start the problem. So it starts off with negative 2/5 is the second number. And if you want to rewrite negative 2/5 as a decimal, there's a lot of ways to do it. But if I multiply by 2 over 2, I get to 4/10. And I know that 4/10 is the same as 40/100, which as a decimal can be written like this. So I'm just going to start by rewriting this problem. So it's minus negative 0.40. Alright, and I'm just focusing on this first part. So I rewrote this fraction as negative 0.40. Alright, so then to figure out what that equals, what I could do is I can use an open number line. I have 0. We're going to start below 0 in the basement or below sea level, and we're going to start at 0.75 negative, and then we're subtracting a negative, which I think back to the house problem, that's like getting rid of weight, and when we got rid of weight from the balloon house goes up because it doesn't have as much weight. So I know we're going to go up by this much. So I'm going to go up by 40/100. I also know we're not going to pass 0 because we're starting 75/100 below. So to go from there up, in a way it's like subtraction because we're getting closer to 0, and you should end up at 0.35 or 35/100. So the answer to this first part right here is negative 0.35. Okay, so now what we're going to do is we're going to bring down this next part and solve the second integer problem that's hidden in this. Alright, so I need to take negative 35 hundredths and add it to 4 tenths. Be really careful, that's not the same as a 4, that's basically like a 40. It's 40 hundredths. And it really helps a lot of students to rewrite it like that so that these are in hundredths and those are in hundredths, so it's easier to add them. So now that I have that, I'm going to come down here, again, make an open number line. We have negative 35 hundredths down here, and this time we're just doing regular adding, so we're going to go up, and we're going to go up 40 hundredths. And I see that that's more than 35 hundredths, so I know we're definitely going to make it to 0. And then all that's left is going to be 5 hundredths, because those two together add up to 40. So our ending spot is 5 hundredths. Alright, so that's the answer now to this whole first part. That whole first part is the same as 5 hundredths. Alright, and now we're down to the very last part where we're adding negative 3/4. First, negative 3/4, just for a second, write it like this. A lot of kids are getting really good, a lot of you guys are getting really good at writing this as a decimal. That's like 3/4, which is 75 hundredths. So basically we have a new problem. The final problem is 5 hundredths plus, and it's negative, so negative 75 hundredths. And to set up our final integer problem on an open number line, I'm going to start at 5 hundredths, and then here we're adding a negative, which again, thinking back to the Up movie, is like he's adding weight to his house, or like a bunch of birds flew onto his house when it was in the air. That's going to drag the house down, and we're going to go down 75 hundredths, which is definitely going to take us to 0. So we could start by going down to that friendly number 0. And then we already went down 5 hundredths out of a total of 75, which means we have 70 hundredths left. And that's going to get us to the final answer, which is negative 70 hundredths. And when I look at the state test possible answers here, I see that they have this answer, which is 7 tenths, negative 7 tenths, which is equivalent to negative 70 hundredths. Hopefully this made sense to you. I know it was a very hard problem, but thank you for taking the time to check your work and to do the best that you can. All right, guys, see you tomorrow.